Every time you unlock your phone with your face, translate a sentence instantly, or watch an AI generate an image, one technology is working behind the scenes: deep learning. But despite powering so many modern AI systems, its core idea is surprisingly simple. Information enters from the left, travels through multiple layers, and finally produces an output. Each layer transforms the data a little further, helping the network discover patterns that humans would struggle to describe manually. That's exactly what deep learning is: building neural networks that learn those patterns directly from data instead of relying on handwritten rules. Before we dive deeper, let's understand where deep learning fits. Artificial intelligence is the broad field focused on building systems that can perform tasks requiring intelligence. Inside AI is machine learning, where instead of writing explicit rules, we let models learn from the examples. And inside machine learning is deep learning, which uses neural networks with many layers to learn increasingly complex patterns. So these aren't competing terms, they are nested. Artificial intelligence contains machine learning, and machine learning contains deep learning. Each level simply becomes more specialized. Now let's look at the smallest building block of a neural network: the artificial neuron. A neuron receives multiple inputs, but not every input is equally important. That's where weights come in. Each input is multiplied by its corresponding weight, telling the neuron how much attention it should pay to that input. The weighted values are added together, a bias is imputed, and the result is passed through an activation function. The activation function decides whether the neuron should activate and introduce nonlinearity, allowing the network to learn much more complex relationships. The output of this neuron then becomes an input for the next layer. Individually, a neuron is simple. Together, millions of them become incredibly powerful. So, why is it called deep learning? Because instead of using just one layer, we stack many of them together. The first layer learns simple patterns from the input. The next layer combines those patterns into more meaningful features. Every new layer builds on what the previous one has already learned. Rather than jumping directly from input to output, the network gradually transforms the information through multiple stages. Each hidden layer creates a richer representation of the data, making it possible to solve problems that would be impossible with a shallow network. The depth of the network is what gives deep learning its power. Now comes the most important question: how does the network improve? It starts with a forward pass. The input moves through the network and a prediction is generated. That prediction is compared with the correct answer. The difference between them is called the loss. A large loss means the prediction was poor. A small loss means the network performed well. Now the learning begins. Using backpropagation, the error travels backward through the network. Every connection receives feedback about how much it contributed to the mistake. The weights are adjusted slightly to reduce that error. This entire process repeats over and over again across millions of examples. Each update is tiny, but together they gradually teach the network to make increasingly accurate predictions. Let's bring everything together. A neuron performs a simple computation. Neurons combine to form layers. Layers combine to create a neural network, and backpropagation continuously updates the weights so the network learns from its mistake. That's the complete foundation of deep learning. Whether it's image recognition, speech understanding, language translation, recommendation systems, or modern generative AI, they all build upon the same core principles. Once you understand this law, from neurons to layers to learning, you have understood the idea that powers many of today's most advanced AI systems. Thank you, and I'll see you in the next one.